Hey everyone, today we're going to learn about graphing functions and what that looks like and then reading functions from a graph. So let's get started. First of all, I might give you a situation like this. Please graph the function x plus 3y equals 15 for this domain. Now, first thing you should notice is the domain is not all reals or not all numbers. It's just for numbers. And those are the possible inputs. So that's going to be our x, and I'm just going to write those four numbers in the column 0, 3, 6, and 9, because that's all the domain is. Well, how can we find out what the y is? This function, x plus 3y equals 15, is not how you typically see a function. We like seeing them in y equals format most frequently, because then you can just plug in the x and it's just calculate. What we're going to have to do is we're going to have to plug it in and solve. So let's rewrite this function down here, but I'm going to leave the variables blank. So blank plus 3 times blank equals 15. The first blank was our x. We know what that is. That's 0 in this first case. We don't know what y is, so I'm going to put the letter y, and we're going to solve for y to figure out what our output is. So 3y equals 15, because the 0 doesn't change anything. Divide by 3, so y equals 5. So I'm going to write that down up there, and the first point I can plot is 0, 5. Be very careful when you plot these. Make sure you know which one is x and which one is y. For some reason, whenever x or y is 0, it always seems to throw people off. So make sure you take your time and think about it when you're graphing it on one of the axes. All right, let's plug in the next one. So I'm going to leave the blanks there. Let's plug in 3 for x and put y for y because we don't know what it is. Now, as I solve this, and we get to subtract, and then we divide, and we get y equals 4. Notice I'm doing the same thing over and over and over. So in this case, it might be nice, I'm not going to do this here, but in the future it might be nice to solve for y first, leaving x by itself, and then you have a formula where you can just plug in x and get y out. That would be really nice, but I'm not going to do that here. Let's plot that point, 3, 4. And what I want you to do is I want you to find those 2 points now. And I'm going to get you started on the point for 6. That's where we plug in 6 and y right there. So solve for y, that'll be the y value for 6, and then do the same for 9 and put the 9 where the x is in our function up here. Okay? Also, plot those points. Alright, now that you've got the points plotted and found out what those y values are, the question is, should we connect the dots in that graph? And the answer is no, because the domain, that's what we said right here, the domain is just those points. It's discrete. Remember that discrete means separate points, whereas continuous means they would be connected. In this case, the domain is discrete. If I don't say what the domain is, it means all possible numbers, all possible inputs. So then it would be continuous, and then we would connect the dots. All right, let's graph this function now. Notice I don't ask what the domain is. That means anything we could plug in. I'm going to pick a handful of values, and I'm going to make a table here. You're going to need to make one too. Just to check and see, all right, well, what does this look like? I don't even know where to start. -3 to +3 going by ones is a good little section to test out. And if this little section doesn't work out for you, you can always try a little bit to the right or a little bit to the left of that. So let's plug in -3. And first of all, you notice that I'm going to rewrite the function, but instead of x, I'm going to leave x blank. I'm going to plug in -3. There's -3. -3 squared is +9. So 9 is the y value. And I'm going to go ahead and plot that point, -3, 9. Remember the x and the y. All right, let's use the same equation, y equals blank squared, x squared. Instead of x, I'm going to put -2. Plug the -2 is the input, and -2 times -2 is +4, so 4 is the output. And I'm going to plot that point also. And I'm going to keep doing this, plugging in -1, I get +1. Plugging in 0, I get 0 because 0 squared is 0. Plot that point. Plug in 1, I get 1 again. And plug in 2, I get 4. Lastly, plug in 3, I get 9. And notice how I've been plotting these as we go. So you see I've got all these points, and because this is a function and it's not discrete, it's continuous, and it just says graph the function, then I need to connect those dots because I know I could plug in 1.5 or negative 2/3 or any number between any of those numbers I've plotted. So I'm going to try to make the curve as smooth as possible. And what we made here was, hopefully your graph looks better than that, we made something called a parabola. Okay? Now you do want to cap it off with these arrows up here going that way and that way, because what these arrows mean, this arrow means it keeps going up and to the left, and this arrow means it keeps going up and to the right. And those numbers, even though they get steeper and steeper, they're always getting steeper, they are going all the way to the left and all the way to the right. A parabola, by the way, is this specific kind of curve, and we're going to see it more and more often. And I'm just going to keep sharing with you guys what it looks like. It does either go up on both sides or go down on both sides, but if it goes up on one side, it has to go up on the other side. All right. Next, we're going to graph this function. You notice there's no y here. That's because y is the same as f of x. This time I'm going to start at -1 and then put in 0, 1, all the way up to 4. You'll see why in a little bit once I graph this. Again, if you're not sure where to start, it's always a good idea to start with 0 and see whether you think you should go right or left from that point. So let's plug in -1 into the function. -1 is the input. So 3 times x, that's -1, minus 5 is -8. So the output is -8. And I'm going to plot the point -1, comma, -8, all the way down there at the bottom. All right, I'm going to go ahead and write all of these down because you see we're doing the same thing over and over if you haven't picked that up. It's especially nice when you have function notation because you plug in, for example, 0, you just put it where x is, and 3 times 0 is 0, so it's -5 is the output. Plot 0, comma, -5 is right there. Let's plug in 1, we get -2 as the output. Plug in 2, you get 1 as the output. Plug in 3, you get 4 as the output. And plug in 4, you get 7 as the output. Now notice that these make a straight line. So I need to connect the dots because I didn't restrict the domain just to a few points. I didn't say what domain is at all. So the domain in this case is whatever you're allowed to plug in. In this case, it's all reals. So connect those dots, draw little arrows at the top right and the bottom left to show those keep on going. We just can't show it on our graph. And, whoops, you guys have that copied down. That is the graph of that function. Notice some key features. We're going to get into this a little bit more, but you see how that's a -5 right there? It's no coincidence that that is a -5 right there. And another thing that happens, you see how every time we take a step to the right, we go up 3. That is no coincidence, has to do with that one. Take a step 1 to the right, go up 3. 1 to the right, go up 3. So that is called the slope, but we'll get to that another day. All right. Last thing, what if I give you a really ugly function? It's not super ugly, but some of you guys really don't like fractions. And let's say I give you the graph of this function. So see, I've already graphed it. I just want you to fill out this table. We have two options. We could plug in the numbers, x, -2, 0, 2, and 4, plug it in here. Or we could use the graph to find out what the outputs are. Now, if you remember, given the graph, we have x is the x-axis, that's the horizontal one, and y, that's the vertical axis. Remember that this line is just a bunch of points all connected together because there's so many points. So if I look at x as -2, that's the input, that's right here. Let me draw a dotted line up or down until I hit our line, our red line, and that is going to be right there at -7. Well, -7 right there is the output. So I just found the output without having to calculate anything. Let's do the next one. 0 is right here. That's a dotted line all the way down to -4 is the output. Remember, this is just the way points are. Every point is an input-output pair, where the input is the x and the output is the y. If we look at 2, 2 is right there, it goes down to the line, and that output is -1. If the input is 4, I want you to go ahead and figure that out. All right, do you guys figure it out? And then the output is +2. So if I give you the graph, it's much easier to try to find the outputs just by using the graph, and we'll definitely do some more practice that way. All right, thank you for watching.